I'm Elizabeth, and I am representing Sandia National Laboratories in sunny Albuquerque, New Mexico, USA. Today, I'll be presenting a few lessons learned based on our user research that we conducted in 2021 on an explainable artificial intelligence, or xAI, tool that was deployed in a cybersecurity setting. Let's see. So I'd like to take a moment to thank the team who made this research possible, especially first author Megan Nair-Yu, who is on the USEC 2022 program committee. And thank you to our principal investigator, Mike Smith, for providing funding and leadership for this research. So as you saw in the title, our research focused on explainable artificial intelligence, or xAI, and I'd like to very briefly go over this. Explainable AI refers to how well a model's output or decision is understood by the user. In our research, the machine learning algorithm of interest was aiding cyber analysts as they determined real-time whether a cyber incident was malicious or benign. In this case, for each incident, the classification tool would simply display to the user the output for that instance. Output would be the word malicious or benign. Another way, however, to present this output could be, in addition to displaying the word malicious or benign, to display why the model came to that conclusion for this particular instance. With additional information on the why, this model becomes explainable to the user according to xAI. So why are we interested in explainable AI? Well, some modeling techniques like neural networks, SVMs, random forests, and others are so complex that they are not interpretable to humans. Other classification models like logistic regression can be more easily interpreted by humans. When we think about explainable AI, we should consider 2 points of view with differing user needs. One point of view comes from the model developers or engineers. Model developers want to ensure the model performance is as good as it can be, of course. The second point of view comes from the end user of the model's outputs. In this case, these are our cybersecurity analysts, who, we theorized, might want to better understand the context of the output in terms of the model's inputs, the uncertainty of the model, and how to best interact with the model itself. So I like to always in my presentations talk about bottom lines up front. So here's the bottom line. The lessons we learned from our research. Essentially, we learned 2 central lessons around xAI usability research. These lessons are regarding 1, the design and deployment of new tools in operational settings, the real world in the wild, and 2, the implementation of effective data collection processes in these live environments. So I'll start with the lessons learned around new cybersecurity tools. First, our research found that adding an explanation to a pre-existing AI tool did not change the behavior of incident handlers in a live cybersecurity setting. Second, we found that the placement of a tool in terms of its location on a specific screen or program or menu is extremely important for a live operational context. Third, tool developers should understand the live operational context of the cybersecurity environment prior to developing an explainability tool. And finally, regarding cybersecurity tools, we learned that developers should aim to reduce complexity of the task or environment, or at the least, not add to the complexity of the environment. Next, our research relied upon instrumented data collection that was programmed to collect data on activities like mouse clicks and hovers with a timestamp for each activity. We found that this type of data collection was non-intrusive for live cybersecurity settings, and also for us, this back-end data instrumentation was novel, and it worked well enough. But we did learn that for future usability research in this domain in a live setting, we need to capture data at a much more granular level and across more tools to better understand an incident handler's process over time. So now I'd like to discuss some details about our research that reinforced our lessons learned. In cybersecurity, AI can be used in many ways, as we've learned. AI algorithms, as discussed, can detect malware, malicious code, and identify phishing attempts, like the last session, among many other uses. One important point here is that incident handlers who are guarding a live network may be skeptical of automated tools. In many cybersecurity contexts, these cyber analysts can use multiple tools to investigate incidents real time. It is often left to the incident handler to make a final determination of whether something is malicious or benign based on a complete investigation across multiple tools, screens, and systems. Another important piece of automated tools is that false negatives, where a truly malicious instance is identified as benign by the tool, can, as we know, have catastrophic consequences. So our research centered around one AI classification model that was already in use by these cybersecurity analysts. The malicious or benign or unknown output from this pre-existing machine learning model was used in addition to other information from a variety of systems and tools. The analysts would weigh all of the evidence gathered from various tools, including this model's output, to make a final determination of malicious or benign for each instance they encountered. Here, you can see that the model output for this instance is malicious. What was added during our experiment and what we refer to as our xAI tool was the explanation piece. In this image, this explanation visually presents the list of features on the left side and the weights of each feature in green or red. In this case, the weights of the features added up to weigh more towards a malicious, to the right, conclusion in the red area than the benign conclusion. So the goal of our research was to analyze these incident handlers' use of model output both prior to and after the xAI tool was added. We collected data for a few weeks pre and a few weeks post xAI implementation. We also collected survey data on trust, confidence, and satisfaction with this xAI tool. Note here that we had a very limited number of data points for the qualitative data, the survey data, due to a very low response rate in this study. But what was of interest to us as user researchers is this. We found that our cybersecurity analysts rarely interacted with the model output, both pre and post deployment of the Explainable AI tool. So, sorry guys. So this finding was surprising to the model developers as well as the xAI tool developers, and this finding is why I'm here today. So now I'll touch on the important outcomes from our research. First and foremost, the deployment of this Explainable AI tool was considered a failure by our research team because the cyber analysts simply did not change their user behavior when the xAI tool was offered. Second, we could not effectively measure trust, confidence, or satisfaction with the xAI tool due to the low response rate to our survey questions by the incident handlers. This is something to take into account when asking live cybersecurity professionals in an operational setting to respond to surveys. Obviously, their number one priority is to keep the network safe. Third, the cyber analyst had to switch their attention to another window to view the xAI tool versus just the output of the AI model. This pivoting made the xAI tool more difficult to engage with. Fourth, cyber analysts use a variety of existing tools to validate model outputs already, prior to the xAI tool's implementation. And finally, we found that the model maintainers and not the cyber analysts were the individuals who were most interested in verifying and thus understanding these model outputs. Perhaps the more appropriate audience for Explainable AI is the model creators and maintainers, not the cyber analysts themselves. So in our paper that we submitted, we have some practical considerations for Explainable AI deployment. The practical outcome was that usability needs to be a priority when developing and deploying Explainable AI tools. Our usability team came up with a way to perhaps bring these xAI developers and the end users together by listing practical considerations for xAI deployment. So our first question, who uses the classification model? To understand this, the xAI developers must identify who uses the model outputs and understand how an explainability component would add to or not these users' ability to accomplish their goals. And perhaps most importantly, the explainable AI tool developers must understand which users actually question how a model works within their normal workflow. In our research, we found that the cyber analysts typically do not question how a model works and instead use the output alongside other tools to come to a conclusion. The second question to ask, in what context will the model be deployed? For our study, we looked at a live environment where cyber analysts were actively monitoring an operational network. Clearly, there were many environmental pressures. So it is important for model developers to ask if the model inputs the features themselves, the names of the features, and the visual displays of the feature weights are meaningful in the environment in which it is used. A third overall question is regarding the relative risk of the model being wrong. How does inaccuracy impact the end user? In other words, is a false negative catastrophic? And what are the consequences if the end user does not fully trust the model outputs? Though our research was unable to evaluate trust in the xAI tool due to low response rates, it would be important for future researchers and model developers to know whether a cyber analyst trusts the model's outputs at all, even prior to an explainable AI tool being incorporated. Finally, what is the risk of the explanation being unclear or incorrect? How does an unclear visual explanation impact the cyber analyst? What are the consequences if the explanation is unclear? For example, could this explainable AI tool be detrimental to an incident handler's final decision of a malicious or benign incident, even when taking into account all of the other systems and tools that they're using? If an explanation is unclear, perhaps the incident handler may come to a different overall conclusion, even if the model's output was actually correct. So to reiterate the takeaways of today's presentation, our research led to several insights around cybersecurity environments where AI is being utilized, and especially where explainable AI is being added. First, we believe that concept testing would reduce time and money spent on tool development. Understanding whether a tool is value added is critical for making good business decisions. Second, new tools that are added for cybersecurity purposes should aim to reduce complexity of the cybersecurity environment. It is well known that cyber analysts already use a multitude of tools and systems to make decisions about security incidents, both large and small. Thus, adding any tool that makes the environment more complex should be avoided. And finally, back-end data collection via pre-programmed system instrumentation can provide valuable insights about how cybersecurity analysts use tools in their decision-making process. Especially important here is capturing each system or tool that is being used at an appropriate level of granularity. Process mining, perhaps, using those timestamps can be used to understand the workflow better. So I wanted to thank you so much for your time, and I'm happy to answer questions during the panel at the end of the discussion. Thank you.